An expected value problem asks us to take a look at all of the different possible events within a specific probability problem, along with their probabilities, in order to find out what is the expected outcome of the specific problem. So, for example, if you are tossing a coin, and you are looking at how many heads you get if you toss it, let's say 5 times or 6 times. The expected value will want to know, out of those 6 times, how many heads should you expect to get? If you were purchasing a lottery ticket, for example, the expected value would ask you to find what your expected winnings would be when you walk away from the lottery. So the first thing that we need to do is we need to create something called a probability distribution chart. The probability distribution chart will list all of the possible probabilities that you have for your particular problem. X is something that we call a random variable, and it is a numerical value that we assign to a specific event. So if we are tossing coin and we are looking for the possible number of heads, you might have a random variable that is 0, meaning you'd get 0 heads. 1, meaning you get 1 head. 2, meaning you get 2 heads. 3, meaning you get 3 heads, etc. And then P of X will be the probability for each of those specific outcomes. Once we have our chart filled in, we can easily find expected value. As you can see, expected value asks you to take each random variable and multiply it times its probability. So you would take x1 times its probability, and then you would take your second x times its probability, and your third, etc., all the way through the chart until you have everything done, and then you would add all of those products up. So let's look at a specific example where we can see this work. Here is a probability distribution chart that I have just made up out of my head. We have our x values being 1, 2, 3, and 4, and we have the probabilities for each of them listed below. Notice something important. When you add up all of the probabilities, 1/6 plus 1/6 plus 3/6 plus 1, the sum of all of those equals 1 or 100%, which they have to. If they don't equal 100%, then your probabilities are wrong. And the reason for this is because total probability is 100%, and that gets divided up between all the possible events within your problem. So if we want to find the expected value, what we do is we multiply 1 times its probability of a 1/6, plus 2 times its probability of a 1/6, plus 3 times its probability of 3/6, plus 4 times its probability of 1/6. Again, notice this is a chart that I just made up out of my head. It's not coming from anywhere specific. So I get 1/6 plus 2/6 plus 9/6 plus 4/6. And when I add all of those up, I get 16/6, which equals to approximately 2.67. And I'm just rounding there because it's 2.666 all the way across. What this means is that my expected value, if I'm looking at all of the different random variables, is going to be 2.67. And the truth is once you have your probability distribution chart, expected values are probably the easiest probability problems that there are to do.